Hello and welcome to the Chapter 10 review. You have to fill this review out and submit it as your homework. So I'm going to go through the whole review. So let's see what happens. A, B, and C lie on circle. Okay, here we go. What is AC called? AC, because the segment has endpoints on the circle, that's called a chord. While line AC, if I were to make this a line, that would be called a secant. A chord is a part of a secant. It's the inner part of the circle of the secant. Remember, there's secant and there's tangent. Alright, well, we'll get to tangent in a second here. Magical, erasable pen. OB is a radius. Next, the best name for segment AB. It's a chord, but there's a better name for it because it goes through the center. It's a special chord called the diameter. Triangle ABC is inscribed or circumscribed in circle O. Each corner of the triangle hits the circle. So because each corner does, and it's inside, that would be called an inscribed. Inscribed in circle O. And lastly, line CD intersects line CD intersects in 1 point. In 1 point makes it a tangent. So that's the difference. This is a tangent. It's 1 point, and this is a secant. It's 2 points. So tangent and secant. Alrighty. Next set of questions here. It says lines X, Z, and Y, Z are tangent. Okay, I need to get out my theorems for this one because even though I have them all in my head, let's see if it'd be helpful for you guys. These are my theorems from topic 10.2. These are going to be helpful for you on your test, so make sure that you have your theorems out. So here's what we got going on. We got like a theorem 10.2. We got a 10.2 here in progress where we got two tangents that are coming from the same point, and that means that there's going to be some congruent stuff here. So let's see here. PX, if drawn, would be, if we drew PX, how would that relate to XZ? Well, there's a tangent, that's a radius, and according to theorem 10.1, a tangent and a radius will always be perpendicular. So this will have to be a right angle right there. I'm going to use the perpendicular symbol to put in there. Alright, next question. If the radius of circle P is 6 and XZ is 8 and this is 6, what does P to Z have to be? Because that's a right angle, we can use the Pythagorean theorem here. 6 squared plus 8 squared equals whatever this squared is, but we can be smart here. That's 3, 4, 5. 3 times 2, 4 times 2, 5 times 2. It's got to be 10. Okay. These questions start over for everyone, so it's good to have an erasable thing here, kind of. Alright, it says if angle Z is 90, so if this is a 90-degree angle, and XZ is 13, then XY is what? Well, according to theorem 10.2, these two pieces here have to be the same length, which makes this also 13. And now we're going to reach back into chapter 9. This is an isosceles right triangle, which makes this 13 root 2. I'm not going to explain that. That's a 45, 45, 90. It's 13 root 2. Alright, next. We have if angle XPY, if this angle here is 100, that's a central angle. That's called a central angle. The angle is at the center. Then what is the measure of arc XY? The central angle will have the same measure as the arc. So that's simply 100. Alright, so central angle is the same as the arc. Next, if the measure of arc XW is 135, and the measure of WY is 125, what is the measure of XWY? Well, I can just add these together. XWY is this whole thing right here. I can just add those together to get 260. And the last question in this set. We have if arc XW is the same as arc WY, then what's the relationship between XPW and this one? These two have to be congruent. If the arcs are congruent, then the angles are congruent, and that would be good old theorem 10.3. If the arcs are congruent, then the angles are congruent. So we could say angle WPY. Alright, next set. Interesting. Alright, let's see here. It says we got circle X and we've got a 120-degree arc for A to C. So A to C is 120, and that looks like a constant for all these problems. So if A to C is 120, what does A to B have to be? Well, according to theorem 10.5, because of the right angle and we're going through the center, here we have it, we're going through the center, and we got a right angle, this is split. It's a line of symmetry, so that makes both of those 60. Next, if AC is congruent to CD, if this chord is congruent to this chord, and according to theorem 10.4, if the chords are the same, then the arcs are the same. That means arc CD is also 120. Next, if XE is equal to 5 and AC is equal to 24, now because of the right angle in theorem 10.5, this is split. So it's 24, but this is also 12 and 12, which makes a nice, if I do the radius right there, that's a 5, 12, 13 right triangle. 5, 12, 13 is one of the Pythagorean triples. You just got to know it. 5 squared plus 12 squared equals 13 squared. Last question for this set. It says if AC is congruent to DC, what theorem allows you to deduce that these two pieces are the same? They're the same distance to the center. That would be, where is that? This one, theorem 10.6. If the chords are the same, then the lengths to the middle are the same. Alright. So 10.6 for us for that one. Next. RS is tangent, which means it just touches. Comes from the Latin word which means to kiss. It's kissing right there. Alright, that's the point of tangency. It says if measure of angle K is 105, then what is the measure of PNL? PNL. Well, here we have ourselves an inscribed quadrilateral. And according to Theorem 1010, an inscribed quadrilateral, opposite angles have to add up to 180. So if this is 105, this angle here has to be 75. Adds up to 180 degrees. Now, next question, it says if the arc PN is equal to 100, so if this arc here is 100, then what's the measure of angle PLN? Well, here we've got a little 10.7 action going on. We have an inscribed angle, and the inscribed angle is half of the arc. So the arc here is 100. That makes this 50. Last question on this set. If the measure of angle K is 110. I'm really getting into this. If the measure of angle K is 110. Then what's the measure of arc PNL? Now that's a major arc. You got to go P, and then N, and then L. So arc PNL is this arc right here. And again, that's 10.7, which says the angle is half of the arc. So that's a pretty big arc coming in at 220 degrees. And what is arc PL? Now that's the minor arc. That's the short way to get from P to L. So if this is 220, this is 360 minus 220, 140. Okay. Alright, last set on this page, and then I'll probably start a new video. Back page is a little bit more in depth. We have arc EF is 120, so E to F is 120. And G to H is 90. Find the measure of angle 1. Alright, that brings in Theorem 1012, which says if you've got like opposite arcs like this, the angle is the average of the two opposite arcs. So what is the average of 120 and 90? Got these like opposite angles sort of thing going on. 120 plus 90 divided by 2, find the average. Alright, so that would be 210 divided by 2, which is 105. 105. Alright, next. It says, this is a really good review of all of the theorems and how they kind of work. It's really good. Alright, E to G says is 100, and D to F says is 40, and we have to figure out what this angle right here has to be. Now this angle is outside of the circle. We got a theorem for that, and that would be this one. Angle 1. If the angle's outside, you do 1/2 large minus small. So you take the large arc and subtract the small arc, subtract and divide by 2. So 1/2 large minus small, which would be 60. Half of 60 is 30. Alright, that's the answer for that one. That must be a 30-degree angle. Oh, it looks like a 30-degree angle. Alright, last question for this set. and that is if pH, which is a tangent, and G to H is 90, so we got a 90-degree arc right here. I bet we're going to use that angle right there. And the measure of the angle is 25. We're going to use the same theorem which says the angle is 1/2 large minus small. So the angle for us is 25 here. The large arc is 90. The small arc is what we're trying to figure out. We'll call that x. Alright. So bring the 2 over, multiply it over, it's 50. And 90 minus x equals 50. X has to be 40. That's the answer for that one, 40. Alright, we'll call this video 1. Stay tuned for